Hello everyone, I'm Arun Kumar, Product Manager for DNS Security. Today I'll be showcasing two unique detections that are part of our DNS security service. Let's first look into one of our DNS tunneling detection capabilities. The goal of the DNS tunneling technique is to exfiltrate your data out of your network using the DNS protocol. DNS in general is a very noisy protocol, so this mode of data exfiltration can go undetected if you're not monitoring your DNS traffic. With this technique, the attacker exfiltrates data using legitimate DNS queries, as you see in the slide. This goes to an authoritative DNS server, which is also under their control. The exfiltration rate is usually very slow, so each DNS query exfiltrates only a few bytes of data. As an example, a simple small command like system info takes about 2.5 hours to be exfiltrated successfully. There are newer tunneling techniques like ultra-slow DNS tunneling, where the data can be sent to multiple authoritative DNS servers under the attacker's control. Each of these DNS servers will be authoritative for a domain name. In all, DNS tunneling is very popular amongst adversaries, as it is easier for an attacker to hide among the regular DNS noise. So let's now jump over to the DNS tunneling demo. Here we have a Palo Alto firewall that is running 10.1.0 PAN-OS release. This particular firewall is licensed for DNS security, as you can see out here. And if we go over to the anti-spyware profile, which is where all the DNS security configurations are, we can see that all the recommended actions or the best practices actions that we specify for all our DNS categories is configured under this anti-spyware profile. DNS tunneling essentially falls under command and control, and you can see the action set for command and control is set to sinkhole. So let's first jump over to a device that is not behind the firewall, so essentially where the traffic will be successfully exfiltrated. For demo purposes, I'm using a test file here, which is called xvel, and this file essentially consists of some random data that looks like credit card information. So we will be exfiltrating this data out of this particular machine to our S3 bucket in Amazon. So for this demo purpose, we have essentially sped up the whole exfiltration rate. So you would see the exfiltration happening fairly fast. So once I click on the exfiltrated file, you would see the exfiltration has now been completed. And now we wait for the file to be downloaded from the S3 bucket in AWS. So now when I click on the download file, you can see that the data that's there in the S3 bucket is essentially the data that we exfiltrated out of a network. So this data essentially got out of our network successfully, and any sensitive information is now in the hands of the attacker. Now let's switch over to another host. This host is sitting behind our firewall. The IP address of the system is 192.168.45.201. Similar to last time, we're going to use the same exact file that we tried to exfiltrate. So you can see it consists of the same data. So now I go over to my tunneling tool and select the file that I want to exfiltrate and hit exfiltrate file. As it does this process, we go back to our threat logs, and now you see that our DNS security service is essentially seeing DNS tunneling attempt happening. So you can see that the application type in use is DNS, and that we have successfully identified traffic going to the hidden domain.com, which is the domain that we have under our control. We own the authoritative server for that. And you can see the action is set to sinkhole. So that means the traffic was detected and successfully blocked. Now let's go back to our host and look at the tunneling tool. So here, if I scroll down and see the file that was downloaded to our S3 bucket, If I open that file, what you will see is there is only very limited or very partial data showing up here. What this means is our DNS tunneling machine learning logic up in our DNS security cloud kicked in after it inspected few DNS packets going through the network. Once it identified that there was tunneling attempt happening, it pretty much sinkholed every subsequent DNS request traffic going through. So the attacker has only limited data that is totally useless at this point. This concludes the DNS tunneling demo. We'll now move on to our next exciting detection, which is called Dangling DNS. Dangling DNS is one of the largely overlooked threat in DNS that could be exploited for domain hijacking. It is pretty common for organizations to create a subdomain, temporary subdomain. Could be for the launch of a new event, new apps, new campaign, could be anything out there. Once the event is over, as a best practice, the DNS zone entry needs to be deleted. Unfortunately, it's a fairly common practice for organizations to forget about that subdomain. So now we have a DNS entry that could be pointing to some third-party domain out there, which could have expired. Now, what an attacker could do is register that third-party domain and redirect traffic intended for the organization subdomain to a site performing malicious activity. Now, let's look at a real-world example. If I look up this access.publichealth.nyu.edu, what you will see is this particular entry has a CNAME record pointing to kc-whitelabel-portal.nyu.gts.com. What that essentially means is any traffic, if you open up a browser and go to access.publichealth.nyu, it's going to get redirected to kc-whitelabel-portal.nyu.gts.com. What our detectors, what our researchers found out was this particular domain, kc-whitelabel-portal, had expired. So it was up for anyone to go and grab that particular domain, register that domain, and host any content they want. Since this domain had expired, if I talk about dangling DNS, access.publichealth.nyu.edu is pointing to an expired domain. So access.publichealth.nyu.edu is a dangling domain. Now, if the attacker goes and registers this kc-whitelabel-portal.nyu.gts.com, they could potentially host any content they want. And anybody browsing to access.publichealth.nyu.edu is being served a malicious content. What our team did was went ahead and defensively registered kc-whitelabel-portal.nyu.gts.com. And we set up a website behind this particular domain. So any traffic that goes to access.publichealth gets redirected to us. As a practice, anytime we find a dangling DNS domain, we reach out to the domain owners and notify them that there is a dangling DNS entry. And we are hopeful that nyu.edu also basically identifies this and fixes this problem on their end. So let's take a look at a system that is not protected by one of our firewalls and see how traffic to access.publichealth.nyu.edu shows up in the browser. So this is a host that is not being protected by one of our firewalls. So what I'm going to do now is go to the domain that I mentioned about earlier. So as you can see here, this is now being redirected to the third-party external domain that I again shared with you earlier. And behind this page, we have put something up that looks like a genuine page of NYU. What could an attacker possibly do here is basically steal your credentials, etc. They could also use it for harming your brand name. There could be other use cases as well. So it could be used as something for delivering malware back to your and infect your end hosts. So there are several different use cases the way this dangling DNS record could be abused. Now we quickly switch over to another system that is behind our firewall, and let's see what happens there. So here I have a system that is behind our firewall. So I browse to the same domain. And now you'll see that since we have categorized this particular domain as Dangling DNS, any traffic going to that particular domain is getting blocked. And if we go back to the firewall logs, we will see that the firewall detected traffic going to it and successfully sinkholed the traffic. So as you can see here, we are detecting that as grayware. So any dangling DNS record is detected as grayware, and the action there is set to sinkhole. Again, you can see that the domain that was browsed to is access.publichealth.nyu.edu. So to a user, this looks like a genuine domain, but it could, as I mentioned, it could be used for any kind of malicious activity. I hope the demonstrations of these exciting DNS security detections were helpful. I would strongly encourage you to try out our DNS security service. It can be enabled with few simple clicks on your next-gen firewall platform or on your Prisma Access solution. And most importantly, it does not require any changes to your DNS infrastructure. Thank you for your time today.